Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over how to name simple branched alkanes. So if you have any questions, make sure you ask tomorrow, but follow along with your notes. Okay, so first thing we need to talk about. Most alkanes are not a straight chain. So we memorized methane and ethane and propane and butane going all the way down to decane. But here's the thing, most organic compounds are branched. And so each branch of a branched alkane, it's called a side chain. So take a look at this picture here, all right? These guys right here, these would be considered branches, okay? And so when we say the word branch, what we really mean is, again, a side chain. So this would be like our, sort of long continuous chain of carbons. And then these guys would be our branches that are going off of them. So there's a very particular way and series of rules for how to name these things. And so underneath it, this is actually the name for this. So 2,5-dimethyl-3-ethylhexane. Okay? And so what we're going to do is we're going to go through the rules for how you'd be able to figure out how to turn this into this name. So there are 5 simple rules for naming branched compounds, and the first is that you want to find the longest continuous carbon chain. And so every compound, if it has branches, is going to have a variety of different ways of, sort of counting their carbons, okay? And so take a look over here at, this sort of picture. There are many ways of counting carbons on this. I could go, just directly across in like a straight line. I could start at the top and sort of make an L shape. I can go backwards, and make a backwards L shape. I could start backwards here. I mean, there are at least 4 different ways of making continuous carbon chains. But I want the longest continuous carbon chain. Okay, so that's kind of our first rule. Now, a sub-rule of the first one is that I also want to number the carbons so that my side chains have the lowest number possible. So let's take a look at those pictures in your notes and see if we can figure out which naming scheme is correct. So these are the pictures that you have in your notes, and we want to make sure that we have the longest continuous chain and also that the side chain, so the branches basically, have the lowest possible number. So one way I can number it is like this. So I could have one carb, this would be like carbon 1, this would be carbon 2, this would be carbon 3, this would be carbon 4, and this would be carbon 5. That's one way of numbering them. I could also number it like this, 1, 2, 3, and then 4. Okay, I could number it going to the bottom like this. So I could do 1, 2, 3, 4, 5, 6, or I can also do it like this on the bottom here, 1, 2, 3, 4, 5, 6. So remember, I want to have the longest continuous carbon chain. So which 2 can I immediately get rid of? All right, so let's cross out this one, because this is only 4 continuous carbons in a row, and then let's also cross out this one. This one's 5 continuous carbons in a row. So one of these 2, this one or this one, are going to be the correct answer. So which one do I pick? So remember, my second sort of sub-rule here is that I want to make sure my side chain has the lowest possible number. Now, a side chain is anything that's not a part of your longest continuous chain. So in this one over here, in this guy, this would be my side chain. And then for this guy over here, this would be my side chain. Okay, so which carbon does that side chain appear on? So let's count. So if I'm numbering it this way, for this guy, I have 1, 2, 3, 4. This is where my side chain appears. It appears on carbon 4. Whereas if I'm numbering it going this way, like this guy over here, now 1, 2, 3, my branch appears on carbon 3, and I want the smallest numbers possible. So I can also cross out this. So this would be my correct way of numbering my longest continuous chain that also gives me my side chain with the lowest number possible. Okay, so what do we call 6 carbons in a row like this? What do we call a continuous chain of 6 carbons? We call that hexane. So that's going to be my base for naming this compound. Now, the next important thing is that we want to circle and identify the name and position of any side chains. And so this is what a methyl side chain looks like. It only has 1 carbon. So methane, methyl Okay, that's why, because methane is CH4, methyl is CH3. Okay, it's a side chain. All right, ethyl. Right here, this is, based off of ethane. So if we were to draw out ethane, structurally, it would look something like this. So notice, again, all we did was we got rid of a hydrogen, and that makes it ethyl. And that's 2 carbons in a row as a side chain. And if we have 3 in a row, that would be propyl. And you can keep going, but these 3 are the big ones and the ones that we're going to be looking at and kind of seeing. Okay, so let's take a look at our picture again. So I have my numbering is correct. I have everything good in my picture down here. So let's circle my side chain. This is my side chain. Now, what type of side chain is this? It is a methyl side chain. Also, what carbon is it at? It's at carbon 3. Okay? So the way I would write that and add to my name here, hexane, is I would say 3-methyl hexane. And that's actually the way that we would write the finished name for this. Because what it's telling me in the name is at carbon 3, I have a methyl, and then I have 6 carbons. Hexane is my base for this. So I draw 6 carbons, and then at carbon 3, I have a methyl group. So let's see if we can name something like this. Okay. First, let's find our longest continuous carbon chain. Okay, so find your longest continuous carbon chain. Okay, so there are many ways of numbering this. Okay, I'll just write down a brief little one for each of them. So I could have numbered it going this way. I could have numbered it just going in a straight line backwards like this. Could have numbered it going in a straight line forwards like this. Could have numbered it going like this and making kind of a loop around. Could have numbered it like this, making sort of an upward loop around. Okay? Each and every one of those is a possible way of numbering this. But which one gives me the longest chain, okay, and as a little subcategory here, also gives me my side chain or branch as the smallest number. Those are the two things I'm looking for. So incidentally, there are 2 ways of doing that. I could have numbered it going like this, 1, 2, 3, 4, 5, 6, which is kind of the obvious one. Okay, and if you did that, you'd still get the right answer. Another way of doing it, which somebody may or may not have come up with, is probably not as obvious, but it also works. 1, 2, 3, 4, 5, and 6. Okay, so either one of those will give you the exact same answer, and that's the beauty of organic chemistry, is that it doesn't matter. As long as you follow the rules, you'll get the right answer. And so I'm going to go with the first one like this because it seems like the most obvious. All right, what do we call 6 carbons in a row? We call that hexane. Next up, got a side chain. So let's circle our side chains and also point out what type of side chain that is and what number carbon it's at. Okay, so I have 2 carbons. That is an ethyl group, and it is at carbon 3. So this is 3-ethyl hexane, and that's the name of it, 3-ethyl hexane. That was only using 2 rules. Okay, so there have to be, we said 5 rules. Where are these other rules? Well, the nice thing is that sometimes if they're really simple, you only have to use like the first 2. But what if there is more than one of the same side chain? So for example, let's take a look at this guy over here. No matter how I number this, I'm still going to end up with 2 methyl groups. So how do we take care of that? Well, the nice thing is those little Greek prefixes kind of make a comeback. So if I see di, that means 2. If I see tri, that means 3. And if I see tetra, that means 4. So for example, okay, now you can write this down too. Like instead, if you have 2 methyl groups, that would be dimethyl. Okay? If you have 3 methyl groups, that would be trimethyl. If you have 4 methyl groups, that would be tetramethyl. Okay? The whole point is if you have a long chain of something, you might have multiple things. Okay? You could have multiples of the same side chain or side group. Okay? Other rule here. We always use commas when we want to separate 2 numbers. So, for example, here's a good example. If there are, like 2, 2, that means there are 2 things at the second carbon. Okay? We use hyphens Okay, only to separate numbers from words. Okay, so another good example. That's why it's 2-methyl whenever we write it. It's not like just 2 and then methyl. It's 2-methyl because we always separate numbers from words using that rule. So let's see if we can actually name this guy all the way up here. So let's find the longest continuous carbon chain. And the nice thing again about this one is actually, there are multiple ways of doing that again. So see if you can write the longest continuous carbon chain for that guy right there. Like I said, multiple ways of doing it, so let's see. I could have done this, 1, 2, 3, and then 4. That would have worked. I could have started up here and made that 1, 2, 3, 4. That's another possibility. I could have also done it going from the bottom, so 1, 2, 3, 4. Again, the nice thing is it doesn't matter which way you go. The only way you can't go is if you worked backwards. So you couldn't number this backwards because if you did that 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, the side chains would happen at a sort of a larger number. So these side chains right here, they have to be on the smallest number possible. Okay, so how would I name this? Well, I need to name my longest continuous carbon chain. So what's 4 carbons in a row called? Okay, that's called butane. So right here, right now I have butane. Now I have 2 methyl groups. Okay, this is a methyl group, and this is a methyl group, and this is at carbon 2, and this is at carbon 2. So how do I write that down? Okay, well, using these last 3 rules, it would be 2, 2 hyphen dimethyl butane. That would be the correct name for this compound. Why? Because, again, I have 2 different methyl groups, both at carbon 2. So I have to point out that they're both at carbon 2, and so that would be the first part here, 2, 2. And then dimethyl, because I have 2 methyl groups, I don't just say methyl, I say dimethyl. And then butane tells me I have 4 carbons in a row as my base. So again, these are like puzzles, so let's see if we can figure out how to name this. Now we have, again, the problem of figuring out what our longest continuous carbon chain is, and also, though, making sure that we hit our side chains or side groups as quickly as possible. So what are some ways of doing that? Again, we could start at any carbon, so I could do this, or I could do this, or I could do that, or I could do that, or I could do that. I mean, there are a lot of ways of doing this. Remember, I want the longest chain. So the way I'm going to do it is like this. 1, 2, 3, 4, 5, and 6. Okay? You could have also done it like this, and again, you would get the same exact answer regardless. All right? So let's circle our side chains. So side chain, and side chain. Now, what type of side chains are these? These are all methyl groups. I'm getting sloppy at writing this. Methyl. All right, what carbon is it at? This is at carbon 2, this is at carbon 3, this is at carbon 4. So how do I represent that? So this would be 2, 3, 4, hyphen, because I'm going to have to put words next. And so I have 3 methyl groups, so that would be trimethyl. And then what is my base for this? Hexane, because I have 6 carbons in a row. So again, I'm piecing this together. Hexane because I have these 6 carbons in a row. Trimethyl because I have 3 of the same side chain group. I've got a methyl here, I've got a methyl here, and I've got a methyl up here. And then 2, 3, and 4, I have to point out where they are on the chain. And so I have one over here at carbon 2, carbon 3, and carbon 4. Let's try this branched alkane. All right, so again, find your longest continuous carbon chain. So I could do this, I could do this, I could do this, I could do this. There are a lot of ways, again, of numbering this, but I want to have the longest continuous chain, and I also want to have my side chains hit as early as possible. So one possible way of getting that to work is like this. 1, 2, 3, 4, 5, and then 6. I could also have started numbering up here, but again, I would have gotten the exact same answer, so it really doesn't matter. So now let's circle our side chains. I've got a side chain here, and I have a side chain there. What are they? This is a methyl group, and this is a methyl group. And so this methyl group is at carbon 2, this methyl group is at carbon 4. So if I wanted to write the name down, it would be 2,4-dimethyl, telling me where my side chains are. And then I have 6 carbons, so that is again hexane. All of these seem to be hexane. That's a little strange. Again, that was my longest continuous carbon chain. Let's keep going. Okay, so longest continuous carbon chain, find it. Again, there are multiple ways of doing this. So let's take a look. I could do this, I could do this, I could do this. Again, many, many, many ways of doing this, but one possibility is doing it like this. So 1, 2, and then 3, 4, 5, and 6. Again, you could have started down here. That would be totally fine too, 1 and 2. But again, we want to make sure that we're a little bit consistent. I'm just going to go straight across like that, just because it looks, sort of familiar enough to us. And then I circle my side chain. Now, what side chain is this? This is an ethyl group, okay, and it is at carbon 3. So I need to write this down. So I would have 3-ethyl, because that's my side chain, and then hexane, again, because I have 6 carbons in a row up here at the top. Now, this is an important point to make. Remember that sometimes if you have side chains, like multiple ones, like if you have an ethyl group and you have a methyl group or something like that, you put side chains in alphabetical order. So that means ethyl gets priority, then methyl, then propyl. So you have to put them in alphabetical order. So let's take a look and see if we can find the shortest sort of, longest carbon chain and get our side chains as the smallest numbers possible. So again, there are many ways of doing this. I could start here, I could start here, I could start here, I could go here. There are a lot of ways of kind of doing this, but again, I want to make sure that I have the longest chain possible and that I hit my side groups as early as possible. And so the only way of doing that correctly is by going like this. 1, 2, 3, 4, 5, and 6. Okay, because I have to hit my side chains as early as possible. And I hit my side chain at carbon 2 here, I hit a side chain at carbon 3 here, I hit another side chain at carbon 3 over here. So now I have to name these guys, alright? So this is a methyl group at carbon 2, this is a methyl group at carbon 3, this is an ethyl group at carbon 3. So by priority rules, I have to put them in alphabetical order. So it's not based on, the number, it's based on sort of the side chain. So 3-ethyl gets priority. Why? Ethyl comes before methyl alphabetically. Next up, now I have 2, 3, because I have 2 methyl groups, and that is another hyphen then, dimethyl. Remember, di meaning the fact that I have 2 methyl groups. And then hexane, because it has 6 carbons in a row. So again, that is actually the name. You can see how complicated some of these can get then. I have my longest carbon chain, I have my side groups taken care of, but that's what it would be called, 3-ethyl 2,3-dimethyl hexane. The last example that we're actually going to be doing, but it also brings up another kind of important little, quirk of naming things in organic chemistry. So as you can see, I have a big, sort of carbon chain here, and I need to figure out what I'm going to do with my numbering, and that's like the first step. So what if 2 side chains are equidistant on the longest chain? Okay, so as you can see, if I go this way and I start numbering, I hit my ethyl group at carbon 3. If I start going this way, I hit my methyl group at carbon 3. So either way I number it, I'm going to hit a side chain at carbon 3. So which one is given priority? Whichever side chain is longer should have the lesser number. Okay? If they are the same side chain, then just make sure the side chains have, the smallest numbers possible. Then it really doesn't matter. But if there is a side chain that is longer, then it has to get priority. So that means that I have 1, 2, 3, 4, 5, 6. Again, I could have also done it this way. 1 and 2, 3, 4, 5, 6 would have gotten the exact same answer, so it really doesn't matter. But why do I have to number it again, kind of going this way? Because I want to hit my ethyl group, because it has a longer, sort of amount of carbons than my methyl group does. And so this would be ethyl, and that would be carbon 3. This would be methyl, and that would be carbon 4. So again, now let's write that out. So I have 3-ethyl, and then I have 4-methyl, and then again I have hexane. For some reason, we keep having hexane examples, and I have no idea why. But there you go. That's, again, how you would write branched alkanes. Alright, so if you're still with me, how can you draw simple branched alkanes? So you can draw alkanes as condensed structures, structural, or line drawings, but the entire point of them is every carbon wants 4 things around it. So for example, if you have 1 carbon in the middle, you can have 4 things around it. If you have a carbon and an H, you are limited. You can only have 3 things around that. If you have CH2 now, you can only have 2 other things around it because you have 2 hydrogens as well. And that's why we always see CH3s at the end of a side chain or at the end of like a longest carbon chain because you're limited. You can only bond to 1 more thing. So these pictures are kind of the important parts of being able to draw simple branched alkanes. So again, here's a really good, this looks way better than my drawings did. But you want to start by drawing the longest carbon chain using only carbons. Okay, you don't want to add anything. You just want to start with just a straight chain of carbons. Then after you do that, then you can start adding your side groups, and then at the very end you can add your hydrogens, making sure that you have 4 things around each carbon. But again, that's kind of how we want to draw these things. So we want to start with our carbon chain, then add our side groups, and at the very end make sure that our hydrogens are all okay. So what we're going to do is we're going to draw the condensed structure, since that's probably the most common one we're going to be seeing, and then we're also going to see if we can draw the line structure. Now remember, the line structures kind of looked like this. They were a little bit, sort of weird. But condensed structure stuff is, again, like I said, it's the most common, but you might see a line structure too as well, so it's important that we kind of go through all of these. Alright, so we have 2,3,4 trimethyl heptane. So again, I want to start with just carbons, so I'm going to draw, sort of my carbons going across. So remember, heptane, by the way, is 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so I just started with carbons. Then I want to add my side groups. So I need a methyl group at 2, 3, and 4. Now it doesn't matter which direction I put these, but there you go. So I'm just going to draw them like this. And so since they're methyl groups, I know they have to be CH3 because that is what methyl means. So CH3. Now I can add all of my hydrogens to the rest of this stuff. All right. So this carbon here right over here at the end, it only has 1 thing bonded to it. So it needs 3 hydrogens to make it happy. This guy in the middle now, so now I'm all the way over here, this already has 3 things, so it just needs 1 more hydrogen to make 4 things around it, as does this guy, and as does this guy. Now what about this guy over here? So this guy only has 2 things, so it needs 2 hydrogens to make that happy, and this guy needs 2 hydrogens, and this guy needs 3 hydrogens at the end. So this is technically the way that we would draw it. So we have heptane going all the way across. Okay, that's what this entire thing is. That's heptane. And then we have 2, 3, 4 trimethyl heptane. Now, how would I draw that as a line structure? So remember, as a line structure, every single little tiny point is a carbon, okay? And so, like, I would start by drawing up. That's already 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons. So again, you can think of each and every one of these as a carbon. Alright, so that's already my straight chain. Then all I've got to do is add on my methyl groups. And so that would be a methyl group, this would be a methyl group, that would be a methyl group. Again, each point represents a carbon. And we don't have to worry about hydrogens for our line structures, so that's literally it. This weird looking thing is actually the line structure for 2,3,4 trimethyl heptane. Let's try a different one. So draw the condensed structure for this. 3-ethyl 2,5-dimethyl hexane. Alright, so we're going to start with our straight chain first. So again, so we have 3-ethyl 2,5-dimethyl hexane. So I need 6 carbons. 1, 2, 3, 4, 5, 6. Okay, now I want to add my groups. So I have 3 ethyl. So on carbon 3, I'm going to have an ethyl group, which looks like this. On carbon 2 and 5, I have a methyl group. So again, it doesn't matter which direction, by the way, I'm putting these. I could put one up if I wanted to. 1, 2, 3, 4, and then 5. So CH3 like that. Now I've got to worry about all of my hydrogens, okay? So let's start with this guy over here at the end. So he needs 3 hydrogens since he only has one thing bonded to him. This guy only needs an H to give it 4 things around it. This guy only needs an H to have 4 things around it. Now take a look at this. This guy already has 2 things bonded, so it needs 2 more. So that'd be H2, okay? This guy, again, needs an H. And at the very end, I need H3. So that gives me my hexane going all the way across. So that would be the condensed structure for 3-ethyl 2,5-dimethyl hexane. Now let's move on to the line structure for this. So again, remember, every single point that you see is a carbon. So I might actually, well, we'll see what happens. I might actually run into my structure a little bit, my condensed structure. So that's a carbon, 1, 2, 3, 4, 5, 6. Well, I kind of cut into my structure just a little bit. Now at carbons 2 and 5, I have a methyl group. And actually, wait, before I do that, let me point out, those are my carbons, right? So at carbon 2, I have a methyl group. That's a methyl group. At carbon 5, so 1, 2, 3, 4, 5. So this guy right down here, that would also represent a methyl group. At carbon 3, I have an ethyl group. How would I represent that? Well, 2 carbons. So it just bends, basically. And again, that weird structure right here is 3-ethyl 2,5-dimethyl hexane. That's the line structure for it. Now this is where it gets even weirder. So look back at the structures you drew and see if you can figure out what the chemical formula of each one is. So I quickly drew the structures that we literally just went through. And so how would I figure out what those chemical formulas were? Well, I need to count all of my carbons, so I'd have to make sure, I count all of the carbons I have. And then I'd have to count and add up all of the hydrogens. So I'd have to add up these guys all over the place and see kind of what I would end up getting. All right, so if you add those up, okay, I kind of did the math already. You get C10H22 for this one. And then do that again. So now we're counting carbons and everything. So I'm counting. Now I'm adding up all of my hydrogens, just like this. I'm adding up all of my hydrogens. And I get the same exact chemical formula. So the whole point is both of those structures that we drew have the same chemical formula. What is up with that? This brings us to a very important property of organic molecules, which we call isomers. Iso meaning same. Molecules that have the same molecular formula but different structures. That's what an isomer is. So take a look at these. These have the exact same chemical formula, all right? But we name them differently, and that's the important part. So take a look. We have 4 carbons in a row for this very first one. That's it. So 4 carbons in a row. What do we call 4 carbons in a row? If it's an alkane, it's butane. Now, what would be the formula for butane? C4H10. Simple as that. Now, what about this guy? So over here, I have 3 carbons in a row, and I have a methyl group kind of on top of it in the middle. So what do we call that? We call that 2-methyl propane. And guess what the formula for 2-methyl propane is? C4H10. So guess what? These are isomers. And the thing about them is they are very, very different from one another. Okay, butane and 2-methyl propane are not the same thing. That's why we don't like using these weird chemical or molecular formulas for organic compounds. That's the reason why we end up drawing these weird structures. And we like, sort of our structural formulas, our condensed structural formulas, our line structures. It's because these are not the same thing. And otherwise we wouldn't know.